Okay. In this section, we're going to be talking about... Shh, I hear a lot of talking. I need that to end. Girls. Shh. In this section, we're going to be talking about the surface area of a cone. Again, as I stated last week, it is very, very important that you make the distinction between surface area and volume. Very, very, very different things, okay? Guys, the difference between this and this doesn't seem very big, but it is huge. It's the same difference between this and this. Right? They're not very big. They are one letter off. Right? However, their meanings are completely different things. They're not even in the same realm together. Does that make sense to everybody? Okay. So I need you to be very cautious with the units that you choose to employ. Yes?
So volume is always cubed.
Volume is always cubed. Area is always squared. Yes. Okay. All right. So we're talking about cones here. Remember, cone is, well, just like an ice cream cone. We should be okay there. But we have a circular base, and so these are not to be confused with a pyramid. Okay? We have a cone. We have our radius here. Take a look on page 632. Right up there at the top, they have a cone there for you, but then they unfold one.
Yeah, I took a picture of that and put it in my book.
That looks kind of weird. The circle is fine, but then the other thing is just kind of like, what?
Like a
Right?
I did that to Sarah earlier.
So there are a few things that we need to know. In order to find the surface area of a cone, what is the formula?
Pi times radius times height.
no.
Pi times radius. It's not pi times radius squared.
No, it's
Pi times radius
Times length.
squared times height divided by 3.
Okay, I kind of agree with what you're saying, and I think you're thinking volume, right? So we have a pi r squared here,
pi times.
but this is not just height.
It's length.
Nope, it is an h. Look on your book, because I'm not giving you this one. It's on page 632.
Yeah, is it the
Lateral area.
Oh, it's the slant height.
It's the slant height. What are they talking about with the slant height?
So it's and that thing.
Sorry, what was that?
So you got the cone point, and it's that.
Like this.
This guy, right?
Yeah.
Okay, this is not to be confused with this guy. Remember, when I talk about a height, it is always going to form a 90-degree angle. This one is different because it's not just a height anymore, is it? What is it? It's a slant height. Okay? So very important for us to remember that this guy, well, I guess it doesn't help if I change colors. This guy right here, that's the one that we're looking for. Okay?
Actually, it probably would work if you changed colors.
Well, I mean, it probably would, but I don't know how well it'll show up. That's red.
Yeah, why is it blue?
That's purple. Yeah.
Yeah, it looks a lot like
I don't know. I'm going to try the other cable eventually.
Eventually.
Yeah. But we're in the middle of a video on this one, so I'm not going to try it on this one. But the YouTube video will come out perfect.
Yay!
Are
Yay.
you sure it won't be blue?
Yeah, no, it's just the projector that shows us blue. The YouTube video records what's on my screen here, which is perfect, including all of my drawings.
Yes.
Okay, so let's assume that the slant height here is 5 inches and the radius is 3 inches. Tell me what the surface area is. Go. Yes. And height. The height comes here from the center of the circle up to the point of the cone. The slant height comes from the edge of the circle to the point of the cone. So if we were looking at it as a triangle, the actual height is one of the legs. The slant height is what we would call the hypotenuse.
Wait, Mr. Kingston, I have a question.
Yes. Marisol.
What if it doesn't give you the slant height?
We'll go over one like that.
Okay. And
What is the radius?
3.
Okay, so we have pi times 3 times the slant height, which is
5
5,
plus
plus pi times 9, right? Okay. So,
sorry.
what do we get?
How many decimal places?
Give it to me to 2 places.
75. You're rounding it.
Don't round it. I just want 2 decimal places.
75.39.
0.39. So would the 3 then go up or would it stay the same?
Go up.
It's
Would
really
go up.
really
75.3 what?
Feet.
4
Feet.
30 inches squared. Very good.
It'll go up, so 75.4.
It'd be 75.4.
Wouldn't it?
Not if we're rounding to the nearest tenth.
Yes,
Oh,
yes.
oh. I see what you're saying.
Not if
My mind was processing something different. Yes, it would be 75.4.
Look, it looks like a word.
Do we have questions?
Like really bad handwriting.
Okay.
To
So the question arose, what if we have a cone then where they give us the old radius, let's say that it's 10 millimeters,
It's faithful radius.
and they give us the actual height.
How dare they?
Yeah, how dare they?
Shame on them and their triangle, isn't it?
Actually, guys, I'm going to change this right here. I'm going to say that that's 3, and I'm going to say that this is 4. That will make it really nice. Do you see the right triangle in there?
Yes.
Okay, so what you do not want to do is to think that this is the slant height. That is not the slant height. What is it?
It's
The normal height.
It's the regular height. Okay, so to find the slant height, whoops, there's another M in there. We're going to have to use good old Pythagoras' theorem.
Ugh. Gross.
So
we have to
it's,
find the hypotenuse.
we have to find the hypotenuse. How do we go about doing that?
Oh,
Marisol,
4 squared
good,
plus 3 squared
good.
equals C squared.
What do I have to remember to do?
Square root.
Square root. So we square root here. So the actual distance there is 5 millimeters.
Wouldn't it always be larger than the actual height? The hypotenuse?
Yes.
Be closer to one of the other.
Yes.
legs.
The slant height will always be larger than the actual height. Okay? How are we doing so far?
Good. Good.
Okay, great.
Yeah.
But we're not done. So we didn't find what we were supposed to find. What were we supposed to find?
The
Double
surface area.
7.
That magic.
The surface area.
Got the magic in me.
It's the same as the last one. We use the same numbers.
It is in fact, yes.
Except it's millimeters squared instead of inches.
It is in fact, yes. Very good. To refresh, what is the formula?
Uh,
2.
pi r times h plus pi r to the square.
It's not h, it's
Plus
height.
pi r squared.
Wait, why did they make it H even though it should be slant height?
They never put H.
They put a cursive H. In there.
Oh, okay. I was like, I was wondering how you could
It
tell
looks
the
like an
difference.
L.
Looks like an
Oh, did they do an L?
Yeah, it's like
Yeah,
an L.
you do.
Sorry, my apologies. Just kidding.
We are wondering.
I'm like, that's a L, so it's length.
Oh my goodness. You just what?
Take that, Cassidy. Okay. Do we have any questions?
No.
Paisley.
Why do they use O for length and slant height?
Because it's the.
Probably just because it's the length of the slant height.
Oh.
Would be my guess. Honestly, though, I have no idea.
You should let her look it up and then she gets 9 points of extra credit.
Marcelo, that's why you always assign it.
Any questions?
Oh,
Okay.
I got one.
Yes.
Why does Cassidy have to take that?
All of you have to take that.
Why?
Wait, we have to take what?
Exactly.
I'm confused. Discombobulated.
I like discombobulations.
Area of the
The lateral area. Shh. Guys, if you want to find the lateral area, it's all of this thing.
So you just take out the not the circle.
You just take out the pi r squared. Yeah.
Okay, but what if it's 2 pi r squared?
What do you mean?
Oh wait, never mind.
Yeah, it should just be pi r squared.
Well, in a cylinder, you just take out the 2 pi r squared.
Right.
Stop thinking about math.
Yeah, to find the lateral area, but the bottom line is, Paisley, your question is very good. All we do, when we find the lateral areas, we remove the bases or base. In this case, there's only one base, so you only take out the one circle, so it's pi r squared. In a cylinder, there are 2 bases, both circles, so it's 2 pi r squared that you take out. Does that make sense? Okay. So... Find me the surface area, and find me the lateral area.
I think you 95. Is that 595 or?
That's a 5.95.
There is a decimal in there.
Okay, so it's 5.
You should make it bigger and not like part of the 5.
Oh, okay, there it is. 5.2.
Pi.
5.25 squared plus 9 squared.
Wait, Sarah, what's the formula again?
This
It's right there in your book.
Down.
Marisol. It's on page 632. Right at the very
I don't want to
bottom.
have to move my neck.
Wow, Maestro.
the most
Squared the 9
The radius.
squared. Oh.
So it's the 5.95 that you would square.
Mr. Hinks.
Oh, wait, what are you finding?
The size.
Oh, the slant height? Then yes, you would square the 9 and square the 5.95. Add those things together and then square root.
What do you round it to?
Yeah, I don't know. You're confused.
On this problem, they want us to round to the nearest tenth.
When you're finding the length.
if you square root it.
Round to the nearest tenth at the very end. Throughout the rest of it, you should hold on to the whole decimal.
Yours is
What
at
if
the
it
very
says dot, dot,
end.
Right, so keep doing the math from there so that it holds that value. Enter it in your calculator a different way. Or just write out as many decimals as you can.
Okay.
Abby?
So, is that formula up there, that's the formula for the surface area, right?
Correct, of a cone.
But then what about, I thought you wrote down the surface area after pi r h divided by.
Yeah, we decided that it wasn't an H, it was an L. I was just misreading
Okay.
from a distance.
Pi times
Yeah.
radius is 5.9.
Okay,
Wait.
I have it.
so it's pi times
Pi times
times the radius times the slant
What is the
height.
radius?
The radius is
5.95.
5.95 times.
Slant height.
Oh man, we don't have it.
It's an ugly number.
That's it's 11.1.
Okay,
No.
how do I find the slant height?
A squared plus
That's
B
B
squared
squared equals
equals
C
C squared.
5.95 squared.
Don't I take the square root of 9 squared plus 5.95 squared?
Yes, you did.
Doesn't that give me the slant height?
Yep.
That's not gonna be
Okay,
pretty.
so I'm just going to put that into my formula.
Oh.
Right, because all I'm going to do is enter stuff in here so that I can just punch this thing into my calculator. Okay?
You need to know your order of operations.
You do, in fact, need to know your order of operations. Okay, then we what?
Then we add pi times the radius squared. So pi times
5 times
5.95 squared.
5.95 squared.
2 pi r.
2 pi r.
That's not 2 pi r, Marshall. That's not 2 pi r, Marshall. Go.
What have you done?
R2 pi. R2 pi. Board.
Okay, what did you guys get?
I got
312.9.
312.9. I got 10.7 meters squared.
Okay,
I got 10.7.
so did I. Okay, I got 312.89 without rounding. Okay, so if we round it to the nearest tenth, we would get 312.9 what?
Meters squared.
Meters squared. Okay, if you did not get this, that would be the surface area. Yes,
How did I get 313.1?
probably because you rounded along the way, or you may have used 3.14 instead of the button pi.
I rounded the side that was, sorry, if you do that stuff.
Here, this guy right here,
Yeah.
you don't want to round him. You don't want to round it all until the very end.
It was 10.8 and then it's 7. You have to put
10.8 and then the 7 repeated?
Yeah. I got 10.
I got 10.7.
What is that? What is that?
Okay, that is not specific.
Got 9.
10.7 number that I can't remember.
Yeah, again, not specific, so I do appreciate you attempting. When I do that, let's see here.
Should I just write that into the my script?
I got 10.788999903.
Yeah, that was it. That was it.
I must have done
5
that.
times 5.
So anyways, if you get a different answer in the end that's close, commonly, it can be either misentering in a number or if you round earlier than you should. So in these cases, class, are you all listening?
Yes.
When do we round?
At the end.
Very, very.
Not until the very end, okay? Does that make sense? Okay. So be very, very cautious when you go through those problems. That was a very good question. Are there any others? Okay. Let's get you started then on your work. You want to do one more?
Yeah.
Sure. Before we get started.
Yeah. Sarah, plus 4.
Okay. Haley?
Does that mean it's going to be the radius is 7, or do we need to cut it in half to make it the radius?
Sorry, I'm trying to tell you that the diameter is 7 inches.
Oh, okay.
Yeah.
Okay.
Which makes no sense based on the way that it's drawn, but we'll just pretend.
Yeah.
Put a 10 in front of it. Or like a 20 or something. It'd be more like.
Or I could just have you solve it the way that it is.
Nah, I don't like it that way. You need to fix it.
20 seconds. Sorry, on the last one I asked you to find the lateral area, by the way, which we did not do. What would I need to take off in order to find the lateral area?
Pi times
Paisley?
5.95.
The last time.
The last part, absolutely. We would need to take this part off. Okay? And that will give you lateral area.
Oh, no, this.
Oh, it's just taken really long.
It doesn't like you.
Yeah, apparently. Has it been delayed this whole time?
Hi.
Yes.
I apologize. Not as delayed as it is
56
now.
million things open. Your brain's open. Look, see, just get more water.
Why are there zebras?
What?
There is water.
Okay, I'm not with you.
Oh, dip, dive, and right. Dab, black and white stripe. Black and white stripe. Black and white
That looks
stripe.
like my finger.
Zebra,
That's why my finger's not
black
black.
and white stripe. Then he run through the savannah.
Why was that area?
But I'm talking about zebras. Because zebras will run through the savannah.
You guys would tell me.
No, actually, that's what bunny sounds like myself. Bunny sounds like yep.
Guys,
I'm really sorry, we're getting really outcast.
Like they're like buzzes.
That's classic. It's cat. I don't know. I don't know what cat looks like.
okay, let's move on.
Did it break?
No, it didn't break. You guys are just not
Are you
focused.
seeing what?
Cat mail.
Yeah, we were gonna watch it, but then my parents decided we couldn't. I don't want my little sister watching it.
It's fun. It's fun. Can you like see? It's really hard to see. It's
Okay, there's your assignment. Get started.
Wait.
I think like the because like